The shark in your head is in warm water. You put it there a long time ago, most likely as a child. The fin cutting the blue, the pale shape sliding under the swimmers, the low note in the music just before it happens. It is quick, that shark. It is bright with sunlight. It lives near the surface, near the coast, near us, and above all it is a thing that moves, fast and with intent, and usually towards someone. Whatever else you know about sharks, you know that one. Most of us have carried it around since before we could spell the word. There is another shark. It answers to the same name and to almost nothing else you just pictured. It lives where that first shark could never follow, under the Arctic ice, hundreds of meters down, in black water a single degree above freezing. It is not a fast animal. It may be the slowest fish in the entire ocean. A person strolling along a beach would leave it behind without trying. It is grey and worn and large. The biggest are as long as the shark you started with, close to 6 meters, and it moves through the dark without the faintest urgency, in no evident hurry to be anywhere at all. The handful of people who have met one in its own water tend to describe the same thing, a vast, calm shape resolving out of the black, arriving so slowly it seems to come from another century as much as from another depth. And it is old, not old the way a person is old the way a cathedral is old. This is the Greenland shark, and as far as anyone has ever been able to measure, it is the longest lived animal with a backbone on Earth, outlasting the giant tortoise, outlasting the great whales, outlasting anything with a spine that we have ever managed to put a number to. The one moving under the ice tonight might be older than your country. The oldest that scientists have ever studied was, as best they could tell, already alive 400 years ago, and quite possibly a good deal longer than that. We can't be exact. The animal keeps no obvious record of its years, and the honest truth is that the finest reading we can take still leaves its age somewhere inside a window 2 centuries wide. There is a shark in the sea right now whose birthday we can only place to the nearest 100 years, and whose most recent possible one still falls before anyone you have ever heard of was born. When it was young, the cities we live in were smaller, or built of wood, or had not yet been imagined. It has been down there the whole time since, through every war you can name, every invention, every person who has ever lived and died and been forgotten, moving slowly in the cold while the entire world we know was assembled above its head. Time on that scale is not something a human mind can hold. Set one life beside it, and a whole life becomes a single long afternoon. Before we go on, a small thing. If a quiet, careful hour with one genuinely strange animal is what you came for, the subscribe button does more to keep a channel like this one alive than almost anything else. And there is a question worth turning over tonight. Have you ever stood in front of something far older than yourself? An ancient tree, a worn stone step, a piece of furniture that outlasted the hands that made it, and felt that small lurch of vertigo, the strange fact of touching something that was already here long before you. Leave it in the comments below. Those answers tend to outlast almost any fact in the research, because that lurch is the whole feeling of this animal. Right now, while you listen, it is down there in the dark at the top of the world, a slow grey shape in water with no light in it, already old when the first photograph was taken, already old when the first trains ran, still moving through the cold exactly as it has for centuries. The years keep passing over it. It keeps going. It was old long before we knew it was here, and it will be old long after tonight is over. Off the west coast of Greenland, in the waters around Disco Bay, the sea barely warms, even in the long light of summer. It sits a fraction above freezing, and the cold of it rises through the hull of a small boat and into the hands of the people leaning over the side, who are watching a baited line drop away beneath them into water so dark it seems to have no floor. They have learned to wait here. This is not an animal anyone hurries. For a long while there is nothing, only the line, the cold, the slap of the sea against the boat, and then, far down, a paleness. Not a flash, nothing sudden, only a slow lightening of the black, a shape gathering itself out of the depth and climbing toward the surface without visible effort. It climbs. It takes its time. And it keeps climbing long after a person expects it to stop, because the thing rising is far larger than the first glimpse allowed, as long as a great white, and heavier than it looks by half, close to a ton, the weight of a small car folded into a single long body. When it reaches the surface, it does not thrash, and it does not bolt. It lies in the water and lets itself be looked at. The head is broad and blunt, almost soft-looking, with two small eyes set into it that seem far too modest for an animal of this size. The skin is the color of wet slate, mottled and marked with old scars, worn smooth in places like a stone that running water has passed over for a very long time. If the mouth falls open, there is a strange arrangement of teeth inside, a top row of thin curved spikes for holding, and a bottom row of broad interlocking blades, angled sideways, the kind that can carve a clean disc of flesh out of an animal far larger than the shark itself. There is something disarming about it, a fish the size of a rowing boat that has risen out of the deep and simply lies there, showing no alarm and no particular interest in the faces above it. The researchers work quickly and gently, measuring the length, fixing a small tag near the dorsal fin, and then they slip it free, and it slides back into the dark, as untroubled leaving as it had been arriving. This is the Greenland shark. Its scientific name, Somniosus microcephalus, means something close to the small-headed one that sleeps, and both halves of that are honest. It belongs to a group called the sleeper sharks, named not for any real sleeping, but for the way they move, which is to say hardly at all, a slow and drowsy cruise through cold water that has given them a reputation as the least hurried hunters in the ocean. It has a cousin in the North Pacific, the Pacific sleeper shark, cut from the same unhurried cloth, and the people of Greenland, who have shared their coast with it for far longer than any biologist has studied it, have their own name for the animal, older than any science, Ekaloswak. For most of recorded history, this was simply the big shark of the north, known to the hunters who now and then hauled one up through a hole in the ice, and to almost no one else. It never made it into the stories the way the white shark did. It was too far away, too deep, too slow to frighten anyone, and it spent most of its existence being, in every sense, overlooked. And yet the strangest thing about it has nothing to do with its teeth. Notice for a moment where the word shark sits in your mind. Almost certainly somewhere warm, a coral reef, a sunlit shallows, a beach with a lifeguard's chair on it. The Greenland shark has spent its whole existence in the exact opposite place. Most sharks cannot survive in water this cold at all. For the great majority of them, the polar seas are a wall they never cross. This is one of the rare exceptions, a shark that lives its entire life in the freezing dark of the far north, beneath the sea ice, hundreds of meters down, in water that would stop a human heart in minutes. The shark of our imagination is a creature of sunlight and the surface. This one is a creature of pressure and cold and permanent night. And the animal built on the same scale as the monster from the films, heavy as a car, carrying those sideways soaring blades, is, to a human being, almost entirely harmless. There is no reliable record of a Greenland shark ever attacking a person. It lives too deep and too cold to meet us often, and on the rare occasions it does, it shows no interest at all. The one shark, shaped like the thing we were taught to fear, turns out to be among the safest large animals in the ocean to be near, a slow, indifferent giant that has been going quietly about its life in the cold the whole time we were scanning the warm water for a fin. We are still, even now, working out where it goes. In 2022, a crew fishing the deep water off the coast of Belize, in the Caribbean, about as far from an ice floe as a shark can get, brought up a large sleeper shark from the cold layers far beneath the warm surface. They studied it carefully, and their conclusion was honest about its own limits. Almost certainly a Greenland shark, or a close relative, or perhaps a cross between the two. They could not say for sure. An animal we have named and measured for 2 centuries, and we still cannot always tell what it is when one appears in the wrong ocean, or how far a single shark might travel in the length of a life. It is a strange gap in the middle of everything else we have learned. By now, the shark from the Greenland fjord is far below again, back down in water the boat's light never reached, settling into the cold at a depth no diver will follow, as untroubled by the whole encounter as it was before anyone arrived. It has taken its life back down with it, and with the life, its age, which turned out to be the one thing about this animal strange enough to reach the rest of the world. Because a body like this keeps no diary. There are no rings to count, no growth lines in the bone, nothing on the entire animal that plainly marks the turning of a single year. That is the quiet impossibility at the center of the Greenland shark. Everything we now say about its centuries had to be drawn out of a creature that, by every appearance, keeps no record of its own life at all. How do you put a number on the age of an animal that seems to carry no clock at all? For most fish, there is a way in. Deep in the head of a cod or a herring sit 2 small stones of calcium, earstones or otoliths, and as the fish grows, it lays a fresh layer over each of them every year, the way a tree lays down a ring. Count the layers and you count the years. Other fish can be read from the growth bands in a fin spine or in the little discs of the backbone. The record is there in the hard parts of the body for anyone who knows how to look. The Greenland shark writes nothing down. Its skeleton is not bone but cartilage, soft and barely mineralized, and it keeps no readable bands. It has no ear stones to count. You can lay a 5-meter shark out on a table, an animal that has obviously been alive a very long time, and find nothing anywhere on it, not a ring, not a line, not a single hard mark that tells you how long. For most of the last century, that was where it ended. Everyone agreed the Greenland shark had to be old. No one could say how old because the animal gave them no way to ask. The answer, when it finally arrived, was hiding in the one place nobody had thought to open: the eye. The lens of an eye is a clear, layered thing added to across a whole life like an onion, with one exception. The very center of the lens, the small knot of tissue at its core, is laid down before the animal is born, while it is still an embryo, and once it has formed, it is sealed away. No blood reaches it, nothing replaces it. The proteins in that core are among the only material in the entire body that stays chemically untouched from before birth until death. A scrap of the embryo kept at the center of the eye, carried unchanged through every year the animal will ever live, which makes it a kind of time capsule. The chemistry sealed into the core of a Greenland shark's eye is the chemistry of the sea it was born into, locked at the moment of its birth and never opened again. In a laboratory, in a hush that feels far too ordinary for what is at stake, that core turns out to be smaller than a lentil and clouded like frosted glass. A researcher works the lens apart under a lamp, lifting away its outer layers one at a time, down and down toward the middle, until all that is left is the first embryonic knot. A fleck of tissue that formed before Isaac Newton was born, held now on the tip of a pair of forceps under a bright white light. Everything anyone wants to know about the animal's age is somewhere inside that fleck. The only difficulty is learning to read it. The reading is done with radiocarbon, carbon-14, a form of carbon that living things absorb from the world around them. The amount of it in the ocean has drifted up and down over the centuries in ways we can trace, and the core of the lens holds the amount from the exact year it formed. Compare that against the record of how the sea's carbon has changed, and the birth can be placed in time, but the clearest mark on that entire record was not left by nature. It was left by us. Through the 1950s and into the early 1960s, the testing of nuclear weapons in the open air poured a sudden flood of radiocarbon into the atmosphere, very nearly doubling it. And in the early 60s, that flood soaked down into the surface of the oceans, a sharp, unmistakable spike in the chemistry of the sea. Marine scientists call it the bomb pulse, and it has become one of the most reliable timestamps we own. Anything alive and taking up carbon in those years carries the spike inside it, like a coin stamped with a date. And this was the stroke of fortune the whole method turned on. The smallest, youngest Greenland sharks, the ones only a couple of meters long, had the bomb pulse sitting in the cores of their eyes. They had been born after the bombs, in the 1960s at the earliest, and that fixed the young end of the clock almost exactly. With those young ages tied to their body sizes, the researchers could build a picture of how the sharks grow, and then work outward through the far larger animals whose eye cores held no trace of the pulse at all, the ones carrying the older, quieter carbon of a world before the tests, and estimate how many centuries their births must lie in the past. The further back the birth, the softer that older signal becomes, and the blurrier the reading, which is exactly why the very oldest ages come wrapped in such a wide margin. The oldest animals on the planet, then, gave up their ages only because, 3.5 centuries after they were born, we detonated nuclear weapons and altered the chemistry of the sea. We read the birth date of a creature from the reign of the Stuart kings using the fallout of the Cold War. The results were published in 2016 by a young Danish biologist named Julius Nielsen and his colleagues in the journal Science. They had aged 28 sharks this way, every one of them female, the largest a little over 5 meters long, and the numbers were hard to hold, even for the people who had produced them. The Greenland shark, they reported, lives at least 272 years. The largest female in the study came out at around 390, give or take 120. It was, by a long way, the oldest animal with a backbone that science has ever found. Older than the giant tortoise, older than the bowhead whale, older than anything with a spine ever measured. If the central figure is right, that shark was born in the 1620s, while Europe tore itself apart in the 30 Years' War, and the ink was scarcely dry on the first printed collection of Shakespeare's plays. This is the point where the story usually slips its rails. The headline that went around the world was that scientists had found a 512-year-old shark. It is a marvelous number, and it is false. No shark in the study was 512. That figure is only the very top edge of the uncertainty on that one largest animal, the far end of give or take 120, and to report it as her age is like meeting a stranger who might be anywhere between 40 and 60 and announcing flatly that they are 60. Nielsen has spent years since gently setting it straight. The honest claim is that she was at least 272 years old, and somewhere between that and roughly 500, and that no one can be more exact than that. But look at what survives the correction. Even the most careful reading, the very lowest figure the method will allow, still makes this the oldest backboned creature we have ever laid eyes on. And the width of that uncertainty is a wonder in its own right. The oldest of these sharks might have been born while Shakespeare was still alive, or 100 years after he was buried, and we honestly cannot say which. We can pin its birth no closer than a stretch of time longer than many countries have existed. The tidy number was never the point. The point is that the answer had been resting in the eye the whole time, written in a language we could only learn to read once we had, almost by accident, left our own signature in the sea. The lens goes back into its small glass tube. The number goes into a row in a table in a paper, and the animal it came from. A 5-meter female who moved through the black cold of the North Atlantic for the better part of 400 years, through the entire building of the modern world, and never once knew she was carrying anything worth counting, is gone now, reduced to a line of data and a birth year we had to guess at. She had kept her age to herself her whole life. She was keeping it still on the day we finally reached in and took it. A Greenland shark swims the way all sharks do, by sweeping its tail from side to side, except that it does so about once every 7 seconds. One slow stroke, then a long pause, then another. Swim alongside one and you would have to keep stopping to let it catch up. Better still, you would not need to swim at all, because a person walking along a beach, in no hurry, hands in their pockets, moves faster than a Greenland shark traveling at its ordinary speed. This is not a figure of speech. Measured carefully, it is the slowest fish in the sea. We know this because, off the coast of Svalbard, in the high Arctic of Norway, researchers fitted several of them with small motion sensors, the same kind of accelerometer a phone uses to count footsteps, and let them slip back into the cold to behave as they normally would. The recordings that came back were almost eerie in their stillness. A few hundred meters down, in a dark broken by nothing for hours at a stretch, the tagged sharks were barely working. A single stroke of the tail, a long glide through black water that never rises more than a degree or two above freezing. Another stroke. There is something faintly unnerving in it. An animal several meters long, moving with less visible effort than a leaf sinking through still water. Nothing about it hurrying, nothing about it seeming even to try. The tail was beating around once every 6 or 7 seconds, and the animal easing forward at roughly 1/3 of a meter each second, the pace of an idle drift, if the shark could be said to be in a hurry about anything at all, which it cannot. Put in terms a body can feel, the figures only get stranger. 1/3 of a meter a second is a little over 1 kilometer an hour, the speed of a slow current, of a canoe left to drift, of not very much at all. Even flat out, in one of the rare bursts of speed it can summon, the fastest Greenland shark ever recorded reached less than 3/4 of a meter a second, barely the pace of a brisk walk. And the slowness does not stop at swimming. The animal grows at something like 1 centimeter a year, sometimes less, which is to say it lengthens its own body more slowly than your fingernails grow. Almost everything this creature does, it does at a tempo the rest of the living world would find unbearable. The reason lies in the cold, and in what the cold does to a body. The Greenland shark is cold-blooded, and it lives in some of the most frigid water any large animal on Earth will tolerate, down close to the freezing point of the sea. At those temperatures, the chemistry of a body slows to a crawl. Every reaction that turns food into motion, every process that keeps a cell running, works at a fraction of the speed it would in warm blood. When biologists finally managed to measure the metabolic rate of a Greenland shark in the cold water of the Canadian Arctic, they found one of the lowest ever recorded for a fish of its size. An engine barely turning over, idling so far down that the animal can go a very long time between meals without apparent cost. the slowness of its swimming, the slowness of its growth, the whole becalmed manner of its life, all of it is the outward face of a body running at the lowest setting biology will allow. And here is where a very old and very tempting idea enters the story. For as long as people have compared the lives of animals, they have noticed a pattern. The creatures that burn fast tend to die young, and the ones that idle tend to last. A mouse's heart races, and a mouse is gone in a year or two. A tortoise plods and sees out a century and more. Set the Greenland shark at the very end of that line. The lowest metabolism, the slowest growth, the longest life of any animal with a spine, and it is hard not to draw a straight line from the one thing to the other, to conclude that this creature lives so long precisely because it lives so slowly. It may be true, it may even be most of the truth. But the honest position is that we do not actually know the slowness causes the centuries, rather than the two simply keeping company, both of them the outcome of something we have not yet put a name to. The neat old rule that a slow life buys a long one has turned out across the animal kingdom to carry more exceptions than the story usually admits. And the Greenland shark has quietly become one of the puzzles that trouble it, rather than a proof that settles it. The link is real enough to feel, and not yet firm enough to claim. What is beyond doubt is the pace itself. Somewhere beneath the ice tonight, one of them is crossing a stretch of black water at 1 kilometer an hour, a single, unhurried sweep of the tail every few seconds, at home in a rhythm that nothing else in the sea keeps, a tempo so slow it seems to belong to the rock and the cold rather than to anything alive. It is a life without haste of any kind, lived far down in the dark, going on and on for longer than we can rightly picture. Which leaves one plain question turning in the freezing water. What is a body made of, that it can run this slow and this cold, and simply keep going for 400 years? On a farm in the west of Iceland, the smell reaches you before the building does, a thick, eye-watering reek of ammonia rolling across the yard, the smell of a cleaning cupboard, of a stable left too long, of something on the turning edge of rot. Its source is a long, open-sided shed with the wind moving through it, where rows of what look like blocks of pale, dark-rinded cheese hang threaded on lines in the cold air. They are not cheese, they are cubes of Greenland shark, and they have been hanging there for months because there is no faster way to make them safe. Fresh from the animal, the meat of a Greenland shark is poison. Not poison in the sense of a quick and violent death, but poison enough that no one who knows the animal would sit down to a raw piece of it. Feed a chunk of the fresh flesh to a working sled dog, as Arctic hunters learned long ago never to do, and within the hour the dog cannot stand. Its legs slide out from under it, its head lolls and swings, and it behaves for all the world like an animal that is falling down drunk. In Greenland there is an old word for a person in that state, shark-sick, and it comes from precisely this. The reason takes us back to the question of what this body is actually made of, and the answer turns out to be the same thing that lets it live where it lives. The flesh of a Greenland shark is soaked through with two chemicals in quantities almost nothing else in the sea can match. One is urea, the very waste compound our own kidneys strain from the blood and flush away in our urine, which is where the ammonia begins. The other is a substance called trimethylamine oxide. Every shark carries some of both. The Greenland shark carries more of the second than nearly any animal ever measured, and it cannot do without them. Down in the cold and the crushing weight of the deep, those two compounds are what hold the animal together. Part ballast, keeping it in balance with the salt of the sea so it neither swells nor shrivels. Part antifreeze, keeping its body working in water barely above ice. Part armor, bracing its proteins against a pressure that would otherwise crumple them. The very chemistry that lets this shark live a kilometer down in freezing black water is a chemistry that nothing else can safely eat. Curiously, the compound with the strange name is not, by itself, the thing that does the harm. On its own, it is close to inert. The trouble begins inside whatever swallows the meat. In the gut of a dog or a person, ordinary bacteria fall on it and break it down into a near relation, trimethylamine, the very molecule that gives rotting fish its stink. And trimethylamine is not inert at all. It slips into the nervous system and works there something like a drug, which is why the sled dog reels and why the old word is about drunkenness rather than illness. The urea, meanwhile, loads the body with ammonia. Between them, a good helping of fresh shark can leave a grown adult dizzy, sick, staggering, and in the worst accounts convulsing. It is genuinely dangerous, but it is worth being exact about it. For all the lurid stories, there is no well-documented case of the meat actually killing a human being. It will lay a person out flat. It will not, as far as the record shows, lay them in the ground. Back at the shed in Iceland, all of that is the reason for the months of patience. The traditional method is slow to the point of absurdity. The shark is beheaded and gutted, then buried or pressed beneath stones and gravel for 6 to 12 weeks so its own fluids drain away and its own enzymes and a whole population of bacteria set to work. Then it is cut into blocks and hung in the open air to cure for a month or more. A team of chemists who followed the process week by week watched the poisons fall away in sequence. Within about 5 or 6 weeks of fermentation, the trimethylamine oxide had dropped below the level their instruments could even detect, and the urea and ammonia were steadily breaking down and venting off into the air. What remains at the end is safe, eaten in small pale cubes, usually chased with a swallow of strong spirit, and an acquired taste even for the Icelanders who grew up on it. And it still smells overwhelmingly of ammonia. But that smell is no longer a warning. It is the leftover breath of the very process that made the meat harmless, the scent of a poison already undone. There is something fitting in the fact that the old stories of the far north reached for the same detail. Long before anyone had measured a molecule, the people who knew this shark best told tales to account for the reek of it. Of a first shark born from a cloth soaked in urine and carried out to sea, of a shark that lived in the chamber pot of the goddess at the bottom of the ocean. The science and the folklore arrive by very different roads at the same strange conclusion. This animal smells the way it does because it is, in some real and literal part, made of the stuff. None of it is new. The chemistry packed into its flesh is a deep-sea inheritance far older than the ice above it, older than the fjords, older than the idea of Iceland, the same trick carried to an extreme that lets its distant relatives endure the pressure of the deep ocean. Across those deep water sharks, the pattern holds with an almost eerie precision. The deeper the animal lives, the more of that second compound it carries, as if it were the toll charged for going down into the dark. And the Greenland shark pays near the very top of the scale. The shark bears it without any sense that it bears anything at all, neither a wonder nor a poison to itself, only a body doing what a body in that place has to do. And this deep fit to the cold and the dark runs through every part of the animal, right down to the one organ we were most certain the darkness had long ago ruined. One line runs through almost everything ever written about the Greenland shark. It is nearly blind, and the reason is not hard to find. Look closely at the eye of almost any Greenland shark ever brought up from the deep, and you will find something living on it. Fixed to the surface of the eye, hanging off it like a pale thread, is a parasite, a copepod, a distant cousin of the crabs and shrimp, a few centimeters long, whitish and vaguely worm-like. It clamps onto the cornea, the clear front window of the eye, and there it stays, feeding for what may be years, leaving the surface scarred and clouded where it grips. Most Greenland sharks carry one on each eye, and for generations the conclusion drew itself, an animal already condemned to permanent darkness, its eyes fouled by parasites, must surely be blind, groping through the deep by luck and smell alone, its ruined eyes little more than useless decoration. And nearly every part of that conclusion turns out to be wrong. In 2025, a group of researchers did something that, oddly, no one had done before. They measured how much light actually passes through those parasite-covered eyes. They took corneas from Greenland sharks and shone light through them, band by band across the spectrum, and read what emerged on the far side. A healthy human cornea lets through about 95% of the light that strikes it. The Greenland shark's cornea, clouded, scarred, the parasite's mark still on it, passed in the blue part of the spectrum that matters most to the animal, somewhere between 2/3 of the light and very nearly all of it. Whatever those numbers describe, it is not a blind eye. And behind the cornea lay a retina in good order. Even in sharks well over 100 years old, tissue that by every reasonable expectation should have been worn away to nothing, there was no such wearing at all. The light-catching pigment packed into that retina, what is more, was shifted toward blue, matched almost exactly to the one thin band of color that still filters down into the twilight of the deep before the dark closes over everything. This is not the leftover eye of an animal that has stopped seeing. It is a working eye, quietly suited to one of the least lit places any large animal has ever made its home. We had made two mistakes, folded one inside the other. The smaller was about the parasite. It sits on a patch of the eye, not across the whole of it, a smudge on a wide pane, not a curtain pulled shut. The larger mistake was about ourselves. We are animals of the daylight, for whom sight is very nearly everything, and we looked at a creature in the lightless deep, saw a worm on its eye, and felt something close to pity, never quite noticing that we were measuring the shark against our own needs rather than its. Vision was never the center of this animal's world, and so the parasite takes from it something it was never leaning on very hard to begin with. Picture it where it actually lives, a few hundred meters down in Baffin Bay, in the last of the light. At that depth, the sea has strained the sun down to a single faint shade of blue, almost nothing, and this is precisely the light the shark's eye can still make use of. In that thin blue wash it can catch shape and movement, the drift of something paler than the water around it. Sink lower though, and even that is gone. Below a certain depth, no light reaches at all, and here the eye finally falls silent, and the rest of the animal takes over. It reads the black, first and above all, by smell. Like every shark, it has a powerful nose, and in deep water, scent is the sense that carries furthest. A thread of blood or decay unspooling on a slow current, and the shark swinging into it from far off and following it patiently all the way to its source, the way a hound runs down a line across a field it could never see across. Closer in, other senses take the lead. Along each flank runs the lateral line, a seam of fine sensors that feel the water itself shift, catching the push and shiver of a body moving somewhere near. And studded around its snout, as on every shark, are hundreds of tiny jelly-filled pores that pick up the faint electric fields thrown off by every living thing. In total darkness, a fish holding dead still and making no sound cannot hide even so. Its beating heart and working muscles leak a whisper of current into the water, and to a shark that whisper has a shape. So the whole picture turns over. The animal we imagined fumbling sightless and pitiable through the deep is in truth moving through a world thick with information. Scent trails, pressure waves, the faint electric fields of hidden life, with a pair of working eyes along for whatever the last blue light can offer. It is not sensing less than we do. Down there, it is almost certainly sensing more. We had been so sure the eye was a ruin that we even built a second story on top of the first. For a time it was proposed that the parasite might glow in the dark, a living lantern dangling from the shark's face to draw curious prey toward its jaws. A tidy notion, spun from a few old reports of a faint light that has never once survived a proper look. The glow and the blindness both. They were ours. Neither ever belonged to the shark. Somewhere in the deep tonight, one of them is doing exactly this, sliding through water with no light left in it at all, the parasite riding quiet on its eye, the animal itself entirely unbothered, reading the black by scent and pressure and the electric hum of everything alive around it. And now it has caught something, a thin ribbon of smell drifting down through the cold, the unmistakable trace of a meal somewhere ahead. It turns without hurry and begins to follow. It is here, at the far end of that scent, that one of the strangest puzzles this animal has left us is waiting. Because what a slow, keen-sensed, patient creature like this one manages to catch at the end of a trail like this is something no one has ever entirely been able to explain. Most nights following a scent to its end holds no mystery at all. It leads to something already dead. The Greenland shark is, before anything else, the great scavenger of the cold deep, the animal that arrives slowly at whatever the Arctic lets fall to the bottom, a fish that died and sank, a seal carcass drifting down through the dark, the offal from a whaling station thrown overboard and settling into the cold. Off Svalbard, researchers who examined the stomachs of these sharks found them full of exactly this, fish above all, cod, halibut, the ordinary catch of the northern sea, and again, the discarded remains of minke whales cut up by the local fishery. None of that requires speed or surprise. It asks only for patience and a good nose, and of those the shark has an endless supply. But now and then, someone opens up a Greenland shark and finds a seal inside that was clearly swallowed fresh, whole, recently taken, sometimes still carrying the marks of a bite, and a fresh seal raises a question that has never been properly answered. How does the slowest fish in the sea catch a living one? Because the numbers make no sense. The shark, remember, barely moves. Flat out in a rare burst, it manages about 3/4 of a meter a second, a brisk human walk and no more. A ringed seal in open water cruises faster than that without trying, and when it is frightened, it can more than double its speed. Put the two in a straight race, and it is no contest. The seal is gone before the shark has properly begun. On paper, a Greenland shark should never, ever get one. And yet, the seals keep turning up inside them, and not half-rotted, not colonized by the small scavenging creatures that swarm anything dead on the seabed, but fresh, as though they were alive, or very nearly, when they were taken. The leading idea for how it happens is a quietly chilling one. Arctic seals have a problem of their own. To sleep, they must rest, and on the ice a resting seal is a meal for a polar bear. So some of them sleep in the water instead, hanging just beneath the surface, rising now and then to breathe. And a Greenland shark, the reasoning goes, is exactly the sort of animal that could take advantage of that. It is slow, yes, but slow is not the same as loud. It pushes no rush of water ahead of it, throws off no warning, gives no sign. It could rise through the black beneath a sleeping seal, without sound, without haste, and simply be there. Hold that image, because it is the one no one has ever seen. A ringed seal off the coast of Svalbard, asleep in cold black water, its breathing slow, the only sound for a long way in any direction. Below it, somewhere in the dark, a shape that may or may not be rising. There is no wake to hear, no shadow to catch. If the idea is right, The last thing the seal would ever know is the water closing. And if the idea is wrong, there is only a sleeping seal and an empty dark, and the shark is somewhere else entirely, nosing after a carcass. The unbearable part is that no one can say which of the two it is. No camera has ever caught it happening. We have the aftermath in the stomachs 100 times over, and the act itself not once. Some scientists are not convinced there is an ambush at all. The absence of scavenging creatures on a swallowed seal, they point out, proves only that the seal was eaten quickly, not that it was killed alive. A slow shark can strip a fresh carcass long before the little bottom dwellers ever find it. No one, as one leading shark biologist has put it plainly, has been able to prove how these animals take seals. The researcher who first proposed the sleeping seal ambush suggested the obvious remedy: fix a camera to a shark's back and wait. And yet all these years later, the film does not exist. The hunt of the Greenland shark remains to this day entirely a matter of inference. One related story is louder than all of this, and it needs correcting. Over the years, Greenland sharks have been cut open to reveal genuinely startling things: the leg of a reindeer, the remains of a horse, in one famous case parts of a polar bear. These finds are real, and they are often retold as proof of a monster that drags land animals to their deaths. They are almost certainly nothing of the kind. A shark that struggles to catch a seal is not pulling down a polar bear. What it found were carcasses, animals that drowned or fell through the ice or died on the shore and washed out to sea, delivered to the bottom of the Arctic and eaten there in the dark by the patient creature that takes whatever the cold sea sends down. The truth is stranger and stiller than the monster, not a hunter of bears, but the undertaker of the far north. What we can do, we do well. We can catch these sharks and tag them and follow them for months at a time. One of them, a 3.5-meter female tagged off the coast of southeast Greenland, known in the records only as SM-13, carried a satellite tracker that logged her long, slow path through the deep, telling us where she went and how far and how deep. What the tag could not tell us was the one thing we most wanted to know. It marked her position in the dark. It could not open the dark up and show us what she did there. We can map the wanderings of this animal in detail and still have no honest idea how it feeds. And so it goes on doing what it has always done, out of sight. Somewhere under the Arctic tonight, at work in the black, clearing away the dead that sink to it, and now and again, in a way we have never once witnessed and cannot fully explain, taking the living too. A slow, patient hinge in the cold machinery of the north, holding a place in it that we can only half make out. Down in the cold, nothing changes. A few hundred meters beneath the Arctic, the temperature has held, give or take a fraction, for far longer than there have been people to measure it. The same near-freezing dark, the same crushing quiet, the same slow water, indifferent to everything unfolding in the light above, and moving through it at that unhurried pace is an animal whose own life is so long that a human lifetime, laid against it, is a single season. There is one more figure to put down, and it is the one that turns the whole thing from a number into something you feel. The age at which a Greenland shark first grows up. A Greenland shark does not become an adult, does not mate, does not reproduce, is not, by the reckoning of its own kind, finished being young until it is somewhere around 1.5 centuries old. The estimates run from roughly 130 years to nearly 180, call it, in round terms, 150. No human being has ever lived long enough to watch a Greenland shark grow up. The longest human life ever recorded ran to 122 years, and even that would have fallen nearly 30 years short. Set a single person beside the animal, and the arithmetic becomes almost too strange to hold. Picture a child born in the same year as a particular Greenland shark. The child grows, learns to walk, goes to school, takes up work, falls in love, raises children, watches those children raise children of their own, grows old and dies, full of years, at 90. And in all of that time, across one entire human life, lived from its first breath to its last, the shark has not yet grown up. It is still a juvenile. Its own first offspring is more than half a century away. The person's children will grow old and follow them into the ground, and the grandchildren after that, a whole line of a family lived out and buried before the shark that once shared the world with their earliest ancestor becomes, for the very first time, a parent. This is the fact that quietly rearranges all the others, every slow thing we have met, the tail that sweeps once in 7 seconds, the body that lengthens more slowly than a fingernail, the engine of its metabolism turned almost all the way down. Every one of them has been building patiently toward a life on a scale we have no honest way to hold in the mind. We are short-term creatures. A single human life is the largest unit of time most of us can truly feel. It is the ruler we lay against history, and from the inside it seems very long. To this animal, that whole ruler, every year you will ever have, is one season, a single turn of a far larger wheel. We understand this instinctively in the other direction and never think to turn it around. We watch a mayfly live out its one day and feel the sadness of a life so brief it seems barely to happen. Set our own lives against the shark's, though, and while it can no more take our measure than a mayfly can take the measure of a summer, we are the mayfly. Our entire existence, first breath to last, would flicker past a lifespan like this one the way a single day flickers past ours. Follow one of them across the human centuries and the strangeness only sharpens. Picture a shark that slipped into the cold in the early 1600s while Europe was still fighting its long religious wars. Through the whole of the 1600s and then the whole of the 1700s, it is a child, not yet grown, moving slowly through the same dark, while overhead the entire modern world is being invented around it. It comes of age at last somewhere around the years the American colonies decide to become a country. And then it simply keeps going. It is a grown animal, an ordinary swimming shark, through the coming of the steamship and the telegraph and the electric light, through the first flight, through 2 world wars, through the night, a human being first set foot on the moon, through the building of every city and the writing of every book that anyone alive has ever read. None of it reaches down to where it is. The wars do not touch the cold. The centuries turn over and over, and the shark keeps its slow appointment with the dark, exactly as it always has. In fairness, all of these figures are estimates, and wide ones. The true age of any one shark comes wrapped in decades of doubt. But the doubt runs the wrong way to rescue us from the wonder. Even the most cautious reading of the evidence, the lowest numbers anyone will stand behind, still describes an animal that spends more than a full human lifetime as a juvenile and lives, at the very least, the better part of 3 centuries. There is no careful version of the story in which this creature is not living on a scale ours cannot reach. And it does every bit of it without the faintest sense that it is doing anything at all. It is not enduring the centuries that would imply it notices them, and there is no sign it does, nor waiting out the ages with some vast, cold patience. It is only a body, moving slowly through cold water, alive, and the enormity is entirely on our side of the glass. The vertigo, the sense of the ground of time giving way under us, belongs to us, the brief animals looking in. The shark just goes on being what it is. Perhaps that is the strangest part of all, that a life so far beyond our scale is being lived at this very moment by something with no idea that it is anything out of the ordinary and no way ever to know. Somewhere under the ice tonight then, a shark is quietly turning 300 or 400 years old in the same near-freezing dark it was born into, keeping a clock that owes nothing to ours. It does not know what year it is. It has never known what a year is. It knows only the cold and the black and the slow work of staying alive, and it has been doing that without a pause since the age of tall ships and candlelight. What all of that time does to a living body, whether anything can carry 3 centuries and not, in the end, pay for them, is a question we are only beginning to open. The animal itself has already answered it in the only way it can. It is still here. The heart of a Greenland shark is not young. It should be. An animal that lives for centuries is exactly the kind of creature we might expect to have found some way to stay new, to hold off the wear that catches up with the rest of us. It has not. When researchers finally looked closely at one, what they found was a heart worn deep by age, thick with the residue of a very long life, and still, up until a few days before it reached the bench, beating. After everything the age of this animal seems to promise, that is a hard fact to take in. The obvious conclusion, the one the mind reaches for, and the one the science itself first leaned toward, is that a creature which lives 300 or 400 years must somehow not age at all, that its long life is a kind of arrested youth, a body that stepped out of time and simply stopped wearing down. It would be a satisfying place to leave the story, the ageless shark, untouched by the years. The evidence does not allow it. In 2026, a team of scientists did the one thing that settles these questions. Instead of guessing, they looked. On the bench lay the heart of a Greenland shark, a dark, dense muscle, still now, that had been beating slowly in the cold only days before and had gone on beating that way for more than 100 years. And under the microscope, that heart told a plain, almost ordinary story. There was scarring laced through the muscle, the stiff, fibrous tissue that clogs an old heart. There was a brown pigment heaped up inside the heart cells, the wear pigment, biologists sometimes call it, the microscopic soot that gathers in any cell as the years pass, a physical measure of time lived. The mitochondria, the tiny power plants that keep each cell running, were breaking down and being cleared away. Everywhere lay the marks of chemical corrosion, the slow rust of simply having been alive for a very long time. This was not a body that had escaped aging. This was aging in full, written into the tissue exactly as it is written into ours. The comparison the researchers reached for is the one that lingers. The damage packed into that shark's heart, one of them said, was the kind that, in a human heart, would not be compatible with life. Put a heart in that condition into a person and it would fail. The person would not survive it. And yet the animals those hearts had come from were fine, healthy, swimming. By every measure the scientists could take, they had been in perfectly good working order, carrying inside their chests the sort of ruin that ought to have killed them, and entirely untroubled by it. So the secret was never that this animal does not age. It ages as thoroughly as anything alive. Every year leaves its mark on the heart, the same marks it would leave on yours. What sets the Greenland shark apart is stranger and quieter, and in its way more moving. It can carry all of that and keep going. It bears a load of wear and scarring and cellular ruin that would stop almost any other heart, and it simply goes on beating, slow and steady in the cold through another year and another. Not the immortality we imagined, but something harder to picture. A body that does not refuse the years so much as absorb them, and outlasts them anyway. It would be dishonest to stop there, though, as if the case were closed. The hearts under that microscope were around a century old, already far beyond any human span, but nowhere near the outer edge of what these sharks reach. The truly ancient hearts, the ones that have kept their rhythm for 300 and 400 years, have never been laid on a bench at all. No one yet knows whether the damage keeps climbing across all those further centuries, or whether at some point it levels off and holds. And the scientists saw the wear, but they never watched the heart at work. The beating was already over by the time the tissue reached them, and so the endurance we are describing is read from the animal's health rather than measured in the act. Even this, the clearest picture we have, is a first glimpse through a narrow window, with the largest question still dark on the far side of the glass. But the shape of the answer holds, and it is not the fairy tale. Somewhere in the deep tonight, a heart is doing exactly what all of this describes, beating slowly in the cold, heavy with the accumulated wear of more years than any human heart will ever see, and not stopping. It is quiet work and unglamorous, and it goes on in the dark where nothing watches it. The animal has no idea its heart is a marvel of endurance any more than it knows its own age. It only keeps beating, which leaves the last question standing where the others fell. If the body truly does pay for its centuries, cell by cell and scar by scar, then what is it? Down in the chemistry of the thing, in the very instructions the animal is built from, that lets it pay that price, and still somehow not fall. Search for the Greenland shark online and, sooner or later, the headlines find you. The 400-year shark whose DNA could hold the cure for aging. The genome that might defeat cancer. The secret to a longer human life written inside a fish at the bottom of the sea. They are seductive stories, and it is easy to see why they spread. An animal that lives for centuries feels as though it must be keeping a secret worth having, and the idea that we might read it straight out of the creature's own instructions and turn it to our advantage is almost irresistible. The real science is quieter than that, and more careful, and, for anyone willing to sit with the uncertainty, a good deal more interesting. It is true that we have, at last, read the animal's genome. 2 separate teams have now spelled out the full sequence of a Greenland shark, the entire chemical instructions set the body is built from, and it is vast, roughly twice the size of our own. Somewhere in a lab, that centuries-old animal from the cold and the dark has been rendered into a scroll of letters on a bright screen, billions of them, running past faster than any eye can follow. And in among those letters are some genuinely intriguing things, extra copies of the genes whose task is to repair damaged DNA, the machinery that patches the small errors a body picks up every day it stays alive. Expansions in the genes that manage inflammation and the immune system, changes in a gene nicknamed the guardian of the genome, the one that helps stop a damaged cell from turning cancerous. On the face of it, exactly the sort of toolkit a hopeful researcher would want to find inside the longest-lived animal on Earth. There is a catch in all of this, though, and it is the whole point. The most dramatic of those findings, the long list of duplicated repair genes, the alteration in the guardian, come from a study that has not yet passed peer review. It is a preprint, a first draft, posted for the wider field to examine, to test, and quite possibly to revise. The genome work that has been properly vetted is far more guarded in what it claims, and the scientists behind it choose their words with real care. Their findings, they write, reveal potential mechanisms that may enable the animal to live as long as it does. Potential. May. Those are not the words of people announcing a cure. They are the words of people pointing at a promising place to begin looking. Because a gene that could help is a long way from a gene shown to help. No one has yet taken one of these repair genes out of a Greenland shark and demonstrated that it does the thing we are crediting it with. What we have is a parts list, an inventory of components that look, to a hopeful eye, as though they might add up to a long life. We do not yet have the machine explained. The distance between reading the instructions and understanding the life is enormous, and nearly all of it still lies ahead. And then there is the loudest claim of all, the one attached to this animal more than any other, that it is cancer-free. It turns up everywhere stated flatly, as though it were settled fact. Here is what almost never appears beside it. No one has ever checked. There is no survey of tumors in Greenland sharks, no study of cancer in the species, no data at all, nothing that has actually looked. The claim is an assumption, dressed up in the clothes of a discovery. Surely the reasoning runs, an animal that lives 400 years must have beaten cancer, and the quiet surely hardens somewhere along the way into a does. It may well be true. Something is holding these bodies together for a very long time, but we have not looked, and until we do, the honest answer is that we do not know. None of this is a reason for cynicism. It is a reason for patience. What is actually happening here is real and early and worth doing. For the first time, we are holding the complete instructions of the oldest living creature with a backbone, and beginning the slow work of asking what in them lets it live the way it does. We want the answer to be in there, a repair kit our own cells run short of, some deep trick of upkeep that human medicine might one day learn from. Perhaps it is. But wanting a thing does not conjure it, and the gap between the hope and the knowing is exactly where all the careful work still waits. No one has found a cure inside this animal. What they have found is a beginning, and a beginning, kept honest, is its own kind of thrilling. The animal, of course, has no stake in any of it. While we scroll its letters across our screens and argue over what they mean, it is where it has always been, a few hundred meters down in the cold and the dark, carrying the whole answer inside it and asking nothing, understanding nothing, needing nothing from us at all. It has been living that answer for centuries on end. It has simply never had any reason to explain it. In March of 2022, on a beach near Newlyn on the coast of Cornwall, a small crowd gathered around something that had no business being there. A shark had washed up on the sand, not one of the sleek, familiar kinds a British shore might expect, but a great grey animal, 4 meters long, heavy and scarred, an unmistakable creature of the deep cold far to the north. It had come up out of a world without light, a world it had lived in for a very long time, and it had died here in the ordinary afternoon, among dog walkers and phone cameras, on a shore it should never have reached. They took it away and examined it, the first time, as it happens, that a Greenland shark had ever been given a proper post-mortem in Britain. Inside, they found the likely reason it had strayed so far from home and so far from the deep. An infection had taken hold in its brain. Meningitis, the first case ever documented in the species, the kind of illness that scrambles an animal's sense of where it is and drives it up and away from where it belongs. But it was a second finding that stopped people short. This shark, 4 meters of it, a full century old by the best estimate anyone could make, was a child, a juvenile, not yet grown, not yet anywhere near able to breed. 100 years into a childhood, it had not begun to finish. It was older, this dead youngster on the sand, than any single person who came to stand and look down at it. And that one fact points straight at the largest empty space in everything we know about this animal. We can read its age out of its eye and its entire genome out of its cells, and the wear of centuries out of its heart. But of the plainest and most fundamental event of its life, how it comes into the world in the first place, we know almost nothing at all. What we can say is modest. The Greenland shark does not lay eggs. It gives birth to live young, fully formed miniatures of the adult, each one roughly the length of a human forearm. The litters may be large. The eggs counted inside a single female can run into the hundreds, which hints that she might carry 200 or 300 pups at a time, though for decades the only figure anyone had was about 10, taken from a solitary pregnant female found back in the 1950s. She remains, even now, very nearly the only one science has ever properly examined. Because what ought to be far better known than any headline about this animal's DNA is simply this: no one has ever watched a Greenland shark give birth. No one has ever seen two of them mate. No researcher working today has so much as found a pregnant female. We do not know where they breed, or in which season, or how long a pregnancy lasts. The guesses stretch to many years, but they remain only guesses. The very first moments of the longest life on Earth take place somewhere in a darkness we have never once managed to see into. There is a quieter kind of not knowing here as well. Think of the animals whose lives we have come to know. The ones with names, whose stories fill books, whose individual histories we follow across years. This one has none. It is too deep, too rare, too slow ever to surface into that kind of acquaintance. The few individuals researchers manage to study are known by strings of letters and numbers, never by names. We can prove, to the decade, exactly how old a living Greenland shark is, and we cannot point to a single one of them and tell you who it is, where it has been, what its life has held. It raises a question easy to feel and hard to answer. What does it mean to know a creature this well and this little at once, to hold its age to the year and its whole genetic text in our hands, and never to have seen it do the most ordinary thing any animal does, which is begin? So the mystery does not close over, it only opens wider. Somewhere in the black water tonight, hidden from every camera and every net, Greenland sharks are being born, small pale pups slipping out into the cold, at the start of lives that may still be underway when everyone now breathing is long gone, lives no human being will ever follow or name or truly know. It is an existence lived almost entirely out of our sight. From a first moment we have never witnessed to a length we can scarcely hold in the mind. And a life that hidden and that unhurried, an animal that needs 1.5 centuries only to arrive at its first pup and surrenders not one of its beginnings to us, turns out to be, for those very reasons, one of the easiest lives on this planet to end long before we have any hope of understanding it. A Greenland shark can be killed in about a minute. To replace it, to grow another one all the way to the point where it could breed and take that animal's place, the sea needs something like 150 years. 1 minute against 1.5 centuries, that single lopsided sum governs everything that happens to this animal when it meets us, and none of it falls in the shark's favor. Picture a longline set for Greenland halibut in the Davis Strait, off the coast of Canada, kilometers of baited hooks lying along the cold seabed, and, up on the surface, a boat and a winch, and the diesel thud of the engine in the freezing air. The line comes up. Tangled in it, among the halibut, is a shape far too large to be one, a vast grey bulk, dragged slowly out of the dark by machinery streaming water, its weight coming down heavy and awkward on the steel deck. It is a Greenland shark, and it may have been alive for 200 years, or 3. Nobody on the boat wanted it. It is what the fishery calls bycatch, the wrong thing on the hook, an accident, a byproduct of the search for something else. Some of these sharks are worked loose and slip back over the side, roughly half do not, killed where they thrash against the line or already dead by the time they reach the surface, hauled up into air and light and engine noise about as far from their own world as an animal can be taken. A creature that was swimming before the boat's country existed, that carried 3 centuries through the dark without a mark from any of it, comes to its end in a few loud minutes on a deck as the unintended cost of a catch of fish. It was not always an accident. For a long stretch of our shared history, we hunted this shark deliberately, not for its flesh, which is close to poison, but for the oil held in its enormous liver, which we burned in lamps and used to keep our machines from seizing. In the peak years in the early 1900s, the hunt took more than 100,000 of them every year across the northern seas, tens of thousands off Greenland alone, tens of thousands more off Norway. It is a staggering figure for so slow an animal, and it carried on in one place or another for centuries. And when it finally ended, in the middle of the 20th century, it did not end out of any change of heart. We simply found cheaper oil elsewhere and no longer had a use for the shark. The reprieve, such as it was an accident too. None of it, the old slaughter or the modern accident, is the kind of loss this animal can absorb. A creature that needs 150 years to raise a single replacement has almost no way to recover from being killed. Take even a few thousand a year, and the modern incidental catch runs to roughly that across its whole range, and the deaths gather faster than the slow trickle of births can ever make them good. The world's leading authority on threatened wildlife now lists the Greenland shark as vulnerable, its numbers falling, with an estimated decline of somewhere between 1/3 and 1/2 of the population. Because a single generation of this animal runs to about 1.5 centuries, the stretch over which that decline is measured, 3 generations, reaches back some 450 years. We are gauging its losses on a ruler that runs to the age of sailing ships. And a warming Arctic is steadily opening the deep, cold refuges it hides in to more fishing than they have ever seen. Worse still, we cannot even say how many are left. No one has ever counted them, and in that scattered, lightless dark, no one really can. Should the species ever begin to recover, the recovery will take longer than any human being now alive will be here to see. There is one small, recent thing to hold on to. In 2022, the countries that manage the fishing grounds of the Northwest Atlantic finally agreed to stop keeping any Greenland shark hauled up in their waters, the first real shared protection the species has ever been given. One conservationist put it in the only terms that fit. It was a long time coming, she said, but not a long time in the life of a Greenland shark. It is a small step, and a late one, and it guards the animal in only a corner of its range. But it is a beginning, and after 400 years of taking, a beginning is not nothing. Step back, and what comes into view is a slow thing we are undoing quickly. The Greenland shark is one thread in an Arctic order that took an age beyond our reckoning to weave, a cold, deep, patient balance built over the same vast reaches of time the animal itself is built from. An order like that cannot be put back together on any schedule we would recognize. Once it is unmade, it stays unmade for a very long time. We have learned that we can end in a handful of decades what the sea took an eternity to arrange. Which leaves a question worth carrying up out of the cold. What exactly do we owe an animal whose lifespan makes single seasons of our own, that was old before us and could, if we let it, be old a long time after? Even now, while you listen to this, it is there, somewhere beneath the Arctic, under the ice, or out in the black water past the ragged edge of it. A Greenland shark is moving slowly through the cold. One long sweep of the tail, then a glide, then another, a few 100 meters down, in water a whisker above freezing, in a darkness broken by nothing but the faint blue ghost of the surface and the cold sparks of living things. It is bound nowhere in particular. It is in no hurry to arrive. It is doing tonight exactly what it did last night and last year and a full century before anyone now breathing drew their first breath. To the shark, nothing about this night is different. Nothing about any night ever has been. We have spent all this time trying to take the measure of that animal, and it is worth asking at the end what we have actually found. We have found that almost everything we assumed was wrong. We found a creature of the freezing dark where we expected one of the warm and the shallow, the slowest fish in the entire sea, an eye still working quietly behind the parasite that everyone had written off as a blindfold. We found a body whose flesh is a slow poison, and whose poison is the very chemistry that holds it together in the deep. We found a heart worn through with the damage of centuries that beats on regardless, untroubled, in defiance of everything we understand about the way hearts fail. And we found an age that ran back further than any creature with a backbone we have ever measured. So far back that we could read it only by the accident of our own nuclear bombs, and even then could place its birth no more precisely than somewhere inside a span of years wider than most of the world's nations have existed. Having learned all of that, we find the animal in a strange and painful position, because the one quality that makes it a marvel is the very quality that now imperils it. Its slowness is not a defect to be pitied. It is the whole engine of its long life, the reason a single body can carry 3 or 4 centuries where ours give out at 80. But slowness runs in both directions at once. An animal that needs a century and a half to raise its first pup, that counts out its generations in the same lengths of time we use to divide up whole eras of history, simply cannot make new sharks fast enough to survive us. The patience that carried it, untouched, through ice ages and the rise and fall of empires, leaves it defenseless against a baited hook. Its greatest strength and its deepest frailty are not 2 things, but one, and there is no prizing them apart. You cannot take the endurance without taking, in the same breath, the fragility. They are a single fact, seen from 2 sides. And what becomes of it now, in all honesty, we will never learn. No one can count these sharks, no one ever has, and in that vast, scattered, lightless dark, perhaps no one ever will. Whatever their fate is, it will settle on a clock that is not ours, slowly across centuries, on the animal's own unhurried scale, rather than the quick scale of a human life, or a human career, or a human worry. If the harm of the last 400 years is ever undone, the undoing will take longer than anyone alive today will be here to witness. We do not get to see how this story ends. That is a genuinely strange thing to sit with, and worth sitting with, because it asks something unfamiliar of us. To care about the outcome of a thing we will never live to see resolved. To do right by an animal knowing we will never be thanked for it, and never even find out whether it worked. That is care stripped of its usual reward. It may also be the only honest kind, to feel for a creature that keeps time like this one. There is a hard irony folded into it as well. For most of the long span our 2 species have shared this planet, the Greenland shark was invisible to us, a nameless grey shape that fouled the fishing lines and got boiled down for the oil in its liver, and that almost no one thought to wonder about at all. We are the very first people ever to understand what it is. We are the ones who learned to read its age out of its eye, to spell out its genome letter by letter, to hold its ancient heart in a gloved hand and see plainly what the years had done to it. And we have come into that understanding at the exact moment we have begun to take the animal faster than it can bear to be taken. We arrived 400 years too late to meet it as a stranger, and we may be leaving before we have finished the introduction. But set the animal against the sheer scale of what it is, and the sadness, without vanishing, is joined by something larger. Because the Greenland shark is not merely old the way any species is old, its lineage trailing back into deep time, it is old as an individual, as one particular animal with one body and one slow heart that has personally, physically, been alive for a length of time the mind cannot properly hold. Consider what that means. There are Greenland sharks in the water tonight that were already swimming before the modern world existed at all. Not their ancestors, not their bloodline. The same animals, the same flesh, the same eyes, the same tail beating at the same unhurried pace, have been down there in the cold, straight through the whole of what we call history. Through the building of every city and the toppling of every throne, through steam and steel and electric light, through the two most terrible wars our kind has ever fought, through every song and book and name that has been remembered, and the far greater number that have been lost. The shark felt none of it. It knew none of it. It was changed by none of it. It simply went on moving, one slow beat of the tail at a time, while the entire clamour of the human story played itself out in the light, unimaginably far above its head. It has outlasted, too, very nearly everything that ever shared its world. The next longest-lived creature with a backbone, the bowhead whale, may reach 200 years. The Greenland shark leaves even the bowhead behind by something close to a century. Almost every other living thing that was swimming in the sea on the day it was born has been dead now for 200 years and more. It has outlived generation upon generation of its own kind, the companions of its youth long since settled into the seabed and become part of it. And still it goes on, carrying within itself, entirely unremembered, an unbroken line of living connection that runs from this very night all the way back to a world we now know only from paintings and brittle yellowed paper. It is not a relic of that world, it is a piece of it, still moving, still breathing, still here. And this, in the end, is what an animal like this one leaves behind in you. We tend to assume that life gets ahead by being fast or fierce or clever, by outrunning its rivals or overpowering them or outwitting them. The Greenland shark is the quiet, patient proof that there has always been another way. In the coldest and darkest and least forgiving water anywhere on Earth, life discovered a strategy that is none of those things. It discovered patience. It found the trick of simply lasting, of turning everything down so low that time itself seems to loosen its grip, of asking almost nothing of the world, and in return, being granted centuries. This shark is not the strongest animal in the ocean, nor the swiftest, nor the most feared. It is only, by a very wide margin, the most enduring. And endurance, it turns out, is its own kind of victory. Perhaps the deepest kind there is, because it is the only one measured against time itself, and time is what comes, in the end, for everything else. There is something steadying in simply knowing it is down there. Not comforting exactly, and not frightening either, but somewhere in between. The way it feels to stand in a very old forest, or to hold a worn stone shaped by a river that dried up before there were any people to see it. To know that a single life is being lived tonight on a scale that folds the whole of our history into one animal's lifetime quietly rearranges a person's sense of their own place in things. It does not so much make us small as make us brief. And there is a strange freedom in that, in being reminded that the clock we keep is not the only clock, and that the world still holds patience on a scale we will never be asked to match. So let us leave it exactly where we found it, not on a beach or a deck or a bench beneath a lamp, but where it has always belonged and always been, in the deep and the cold and the dark, at the very top of the world. It is there now, through all the long years we have spent watching it, dating it, sequencing it, arguing over it, marveling at it. It has never once known that we were here. It does not know we finally learned its age. It does not know its name moves through our headlines, or that anyone anywhere has ever wondered about it at all. It does not need our wonder. It does not need our attention. It asks us for nothing, and it never has. It only goes on being precisely what it has always been, a slow grey shape in cold black water, keeping its own long time, indifferent to the surface and to everything that happens there, older than every question we ever thought to carry to it, and entirely unbothered that we asked. Somewhere out there tonight, it is turning, without hurry, back into the dark. The years will pass, it will go on. Let it keep them. Rest now.